Hello all my 3U friends. I am going to be speaking today about function notation. But of course we cannot start a 3U lesson without a joke from Google. Still thinking? Kind of cool, huh? In this lesson you will be able to recognize function notation, and you will also be able to determine the value of a function when given a particular x, and then you will apply function notation to solve applications. In the past, grade 9 in fact, we used y equals mx plus b. At that time we knew that y is dependent on x. Y depends on x. X is the independent variable, y is the dependent variable. And we can say that y is a function of x. So y is the function, the line in this case, and x is the other variable. And we can write it instead of y as f at x. So some function f of x is equal to mx plus b. We're simply replacing the y with an f at x, some function at x. So specifically, we are saying that this y equals 2x minus 3 is some line that begins at minus 3 and goes up 2 over 1 if we want to graph that. We're going to replace this y with an f at x. So then we can just say f at x equals 2x minus 3. So some function of x is equal to 2x minus 3. And we're still talking about the same line. We've just simply replaced the y with an f at x. So if we wanted to determine y, or in this case f at x, at some point, then what we're going to do is we're going to say what is the value when x equals 2, at the point x equals 2. And instead of saying, just putting it in here, which we will do anyway, we say f at 2 equals 2 times x minus 3, and where that x was, you can see it under there still, we're going to replace it with a 2. So 2, this 2, and then x is 2 minus 3. So I get the answer of 1. So the value of the function at x equals 2 is 1, or the value of y when x equals 2 is 1. Let's try one together. So g at x equals 2x minus 5, and we want to find g at negative 2. We will substitute negative 2 in where x is. So g at negative 2 means put a negative 2 where x was in the function. So 2 times negative 2 minus 5. And now we evaluate. So once we complete the substitution and the simplifying, we get g at negative 2 equals negative 9. In a second example, we'll use a more complicated expression, or equation. So we have x squared plus 3x minus 5. We know that this is a quadratic, but we're going to determine this particular quadratic when x equals negative 3. You can see I've put the negative 3 here where the x is here. So it means I want to find the value of y, or the value of the function, at negative 3. So I'm going to substitute and then simplify. So I take this negative 3 and I put it wherever I see an x. So negative 3 squared plus 3 times negative 3 minus 5. Once I do this simplification, I get f at negative 3, so the value of y, or the function, is at when x is negative 3 is negative 5. You can see that this gives us a more explicit way of talking about functions by having f at some value x, negative 3, whereas before we just had y equals. So now we know that this function, the one up here, when x is negative 3, the answer is negative 5. Another way of saying that is that the point negative 3 for x and negative 5 is on this function. So what if we get a little bit more complicated? We now have two functions, and this is probably one of the main reasons why we start replacing y with f, because we want to talk about multiple functions. So if we said y equals 3x plus 5, we can't then say that y equals x squared minus 1. So we're giving them different names. F at x equals 3x plus 5, g at x, so some other function, equals x squared minus 1. And the question says determine f at 1 minus g at 2. So my plan then is to find f at 1, to find g at 2, and then subtract. So you can see that I found f at 1 by substituting 1 in where x was, and I got f at 1 equals 8. Then I looked at g at 2. G at 2, putting a 2 in where the x was, I get 2 squared minus 1. I get 4 minus 1, which is 3. Finally, I'm going to subtract like I've been asked to do. So now I have f at 1 minus g at 2 that I want to do. So in red, I've done f at 1 minus g at 2. F at 1 is 8, so there's the 8. G at 2 is 3, so there's the 3, and I'm subtracting them because that's what I've been asked to do. So 8 minus 3 is 5. So the function f at x being 1 minus the function g at x being 2 equals 5. So the difference between these two functions is 5. In question 4, we have f at x equals negative x squared minus 3x plus 4, and we've been asked to determine 2 times the function at x equals 1. So my plan then is take this 1 and put it in here to find out what f at 1 equals. Once I know what f at 1 is, I just multiply it by this 2. So I substituted 1 into this equation, and it ended up with f at 1 equals 0. Now I just have to multiply by 2, and of course 2 times 0 is 0. So then 2 times f at 1, like I've been asked, means to find f at 1 and then multiply it by 2. F at 1 was 0, now I multiply by 2, and I still have 0. So the answer for this equation is 0. In question 5, it's a little bit different. So we have f at x equals 3x squared minus 2x plus 5. So if x is 1, we would put 1 here, and simplify and solve. But this time f is not 1, x is not 1, x is 3x plus 2. So what that means is I am going to take this whole 3x plus 2 and put it wherever I see an x. So it's going to require a lot more algebraic work. So you can see if I'm going to take this and put it wherever x is, I end up having 3 times x squared, so 3x plus 2 squared, minus 2 times the x, so 3x plus 2, and then add the 5 on the end. Now I'm going to evaluate all of this. So I've substituted this in up here directly into this equation. 3x plus 2 squared, I expanded that to get 9x squared plus 12x plus 4. I've left the rest the same. Now I'm going to use the distributive property to expand the next one. So 3 times 9x squared is 27x squared. 3 times 12x is 36x. 3 times 4 is 12. Similarly, I'm going to do the minus 2 times 3x gives me minus 6x, and minus 2 times 2 gives me minus 4, and then of course the plus 5 from before. Simplifying, collecting like terms and then simplifying, I end up with 27x squared, because that's the only x squared term, 30x, and then 13. So my answer for f at 3x plus 2, using this function for f, ends up being 27x squared plus 30x plus 13. Here's some textbook opportunities. And here are some other opportunities. I think I'm going to give you this one on a worksheet, and then this one you can go check out on your own. Thanks so much for listening, and good luck on your work.